The BE3 alarm code will be discussed in this video. This is the last alarm code detection the drive provides at start when the drive receives a start command. The BE3 alarm code is designed to indicate that the holding brake has not released at the start of a run command. Starting over with the sequence, the drive, any VG Plus drive does a BE2, then a BE1, and then a BE3 alarm code. It's important to note the BE2 alarm code does not reference any encoder signal. It is merely motor torque and a time period. The BE1 alarm code says that based on encoder feedback, the drive is seeing too many pulses. The BE3 alarm code is actually the opposite of that, that within a certain time period, the drive is not seeing enough pulses, which, if the encoder is fully intact, indicates that the holding brake or brakes have not released or fully released, and the result is the motor is not turning at the speed required. The parameters that control this are in the Group C parameters. I'm going to show those to you now. Crane and hoist functions, and it's in the C8 group. No load brake hoist sequence. We have what's called a brake release time. The factory default setting is 0.3 of a second. And a brake release count, which the factory default is 10 pulses. Now, I've modified for this demonstration purposes that we have to see 103 pulses so that I can get this drive to trip out on a BE3. Back out. Give the drive a run command, and I will hold the motor shaft while I give the drive a run command. And there it is. I've generated a BE3 alarm. And the verbiage on the display says brake release no good. So that's basically confirming that the holding brake is not released. I get a little movement of this motor shaft. That's why I had to increase the pulse count out to be able to generate this in this example. Go again. There's 3. I've got 3 consecutive ones, and like all the other BE alarms, when I release the run command, the 4th one will lock the drive up, will not allow any further run commands to be accepted by the drive. And at this point, the alarm code must be reset. Now, the BE3 alarm will be recorded in the monitor mode, standard monitors, and we can look at it in the fault trace. And so because the BE3 has been set, what it's identified as current fault, or you could use the term active fault to describe it, there is nothing in that register. The most recent fault that occurred is a BE3, and as I scroll down, I'll be able to read what the drive was doing. Again, the frequency reference was 60 hertz or full speed. The output frequency was relatively low, the 3 something hertz. And then we have the output current indicating the motor was energized. You notice that the motor speed, which is based on encoder feedback, registers 0, which means there wasn't a perceived enough pulses to indicate that the motor was actually rotating, which is why the drive tripped out. We have output voltage, DC bus voltage, and so on. The motor So if there is a problem with the encoder signal, the drive will pass in its 3 startup BE alarms, the BE2, because it doesn't use encoder signal for the BE2. It will pass the BE1 because the drive does not want to see any encoder signal per se during the rollback detection. But in the BE3, it now must see an indication that the motor is turning. So keep in mind, for troubleshooting, if you can determine the holding brake or brakes are fully released and you're getting a BE3 alarm, check the encoder signal.